Hello class, this is a video tutorial on direction fields or slope fields part 4. In this video we'll be looking at sketching the function from a direction field or slope field, but we'll be focusing on non-standard functions or relations. In the previous set of examples of slope fields, paired with their differential equations, we could recognize easily the graphs of functions we've worked with in the past. But as we've seen in this topic, we encounter differential equations that are non-standard, or are actually just relations. Or the slope field will not be given an equation. So let's take a look at these 6 examples. So here they are, 1, 2, 3, 4, 5, and 6. You can pause at any time and give these a go yourself. But let's actually get to it with sketching these. Now remember, we can pick any point that we like, and we should try and follow the slopes of those points that we've picked. So for example, if I were to pick the point -1, 0. At this point, there's a vertical tangent. But as you can see, the further up we go, the less steep it gets. So there would be a point here where it's vertical, but very quickly it'll start to slope like this. So let me draw this again. It'll slope something like this. Because notice how this tangent should be somewhat applied here as well. So it should be something like this. And just looking at the slope field, there is a 180-degree symmetry. So it looks to be the case that it's graphed somewhat like this. It's a bit of an exaggeration, but let's see what we can come up with. So continuing this. Now remember, we don't need to pass through the given points. Okay, they're just a guide to tell us what the graph should kind of look like. So it looks like it's getting more and more flat. More and more flat. Once again, it's getting close to what looks to be an asymptote. Somewhat like this. Now, thankfully for us, well, for me in particular, I have an iPad. I can just grab this, duplicate it, and rotate it because there's indeed symmetry in this graph. So it should look somewhat like this. So there's one that we could possibly draw. Let's do another. If we were to have picked, let's say, this point here, you can see that following this point, we would get a sketch that looks somewhat like this. And now, thankfully for me, once again, I could grab this. Oops. Duplicate it and rotate this guy. So here are 2 possible sketches for this slope field. Notice how they have some sort of similarity between each other. Okay, so let's do another. You can pause and give this a go yourself. This one, I hope, is rather simple. You can see that the tangent at this point is horizontal. Tangent at this point is vertical. So it looks to be the case if you were to follow this, it should be somewhat like so. Now, hope you can see that this is definitely not a function, whereas this is. I hope you recognize that this is actually just a circle. So here's one, let's try that again. Here's one possible sketch. That's one right there. And another is just the exact same thing, but I'm just going to enlarge it. Oh, nope, sorry. I'm just going to enlarge it like so. So here are two possible sketches for this curve. Okay, let's try it again for this one. -3 plus y. Now notice this is rather tricky in that if you had picked this point here, this is a possible curve. That point there, any point along here, it would generate a straight line, because notice how if we were to follow this, it's stationary, but it doesn't look to be the case that along this x value, there are no changes to the gradient. So if you were to follow this point along here at y equals 3, we would always get a flat curve. Okay, so if you pick that point, very fortunate, it's very easy. However, if you picked a point ever so slightly below, notice how the further down you go from, let's say, x equals -5, the gradients are actually not flat. In this case, the gradient here looks to be somewhat like this. If we could draw more gradients in this slope field, it looks like it's doing something like this. So if I picked this point ever so slightly below and start from here, it looks to be the case that the sketch of this curve might be something like this. Now remember, it looks as if that I'm trying to pass through all the tangents. That is definitely not the case. I'm following the tangents being presented to me. Because remember, there are tangents that can be selected between the slopes that are given in the slope field. So that there is what it would be if we picked a point ever so slightly below y equals 3. Likewise, if you picked a point ever so slightly above, it looks to be the case that it would be a curve. Let's try it again. Somewhat like this. And you can continue like so. So it really depends on which point you pick. So for example, if I picked a point, let's say here, if I picked this point and follow what the tangents are telling me, it would look somewhat like this. Notice how this one that I've picked, and I'm just following, the one that I've picked really doesn't pass any of the drawn tangents there. It looks to be the case that it's just curving down to -infinity from that point. But if we picked it closer to here, notice how it looks to be the case that it's getting closer and closer to this point, but never actually touching. It looks to be the case that it's making an asymptote at this point. And this would be symmetrical along the point above it. So if I picked a point symmetrical on the other side, this would create a symmetrical branch of this curve. So it looks to be somewhat like this. the asymptote is also approaching 0, like this. Okay, so it really depends on which point you pick from, but you should definitely be following the tangents presented to you. Okay, so this is just 3 examples. I'll see you in the next video where we do another 3. Hope to see you then, and best of luck.